switch this over real quick. Okay. So thing off of here, so a little more space. So hopefully everybody had a good break. Kind of in the home stretch here. So where we left off before break was talking about kind of these panel data models. We're primarily looking at fixed effects, right? So we're going to move to kind of the next topic this week, which will be instrumental variables. It'll be really the last kind of new material that we have. So this week we'll look at instrumental variables. This Thursday, we'll have that 6th problem set, which is due at the end of next Tuesday. So basically a week from today. Okay. So the first half of that problem set is stuff that we covered prior to Thanksgiving break over this panel data, primarily looking at fixed effects, autocorrelation with our errors. The second half of it will be all stuff we talked about this week. So as we kind of cover things, kind of looking at the do file that we're using this week, you should be able to kind of start working on completing the second half of that assignment. That's the last problem set that we have. It's the last one that will count towards your grade. We're going to have an in-class quiz today. Spoiler alert. All right. So that should be the final 12th in-class quiz will be today. There's still going to be a 6th quiz. So we have that set of sample questions. I will reference this quiz at the end of class today. So if I forget to do that, remind me to tell you about that before we get out today. But I'll talk more about that 6th quiz. It'll be the 6th and final quiz that'll count towards your grade. Once all those due dates have passed, we'll have all the problem sets in next Tuesday. That 6th quiz will be the last quiz, last in-class quiz here today. That's everything that's left other than the final exam. So I've got that hypothetical grade tool, which I think it's still sitting under the midterm section, but you can find it under the files tab here as well. I'll likely revisit this next week. Once all those grades are in, you know exactly what your score will be in each of those categories, except for the final, and how you can kind of use this to play around with what grade you need on the final to get your desired grade in the class. Also, as a reminder on the syllabus, so our final exam will be final exam week on that Tuesday, right? So it's going to be from 12:40 to 2:40 afternoon. We lucked out. I think I mentioned this prior to break. I'll get an announcement up closer to the date, but we're going to be in this room. So we're not going to be in a different location, at a slightly different time than what we usually have class during finals week. Okay. Next week, since there is no new material, and I think this will benefit you, primarily, I'm just going to be doing review, right? So we've got a practice exam that I put up prior to break. You can start working through that. This is going to be pretty similar to what the final exam looks like, right? If you kind of look at that old practice midterm, right, compare that to what we had in the midterm exam, it's going to be very similar, right? Different data sets, right, but covering similar type of questions and topics. So I would start to try to take a look at this prior to next week. Now, I would expect maybe some of the more recent stuff you want to review a little bit more next week. But really, next Tuesday and Thursday, I'm not going to come to class with any, I shouldn't say that. That's not completely true. Since I have the final exam written, I will probably have some things that I want to make sure we focus on, but I also want to make sure we're focusing on the questions that you guys have, right? I can kind of guess what some of those are going to be, right? But I want you to come to class with questions in mind. That way I make sure I'm reviewing things that you're having more difficulty with than others. So the final is not cumulative. It's everything that we've covered since midterm 2. Now, obviously, we're using concepts about p-values, test statistics, R-squared, adjusted R-squared that we use in the first midterm. But in terms of the module, or I shouldn't say the modules, but the material it covers, it's really just going to be everything since. What's that? Right? That midterm exam, right? So it'll be nonlinear regression, that squared log-log models. We then looked at interaction terms. We then talked about missing data, some of the other data issues, external validity, et cetera, panel data models, and then last topic, which will be this week, which is instrumental variables. So that's what the final will be over. So that's kind of a roadmap where we're going at the end of the class. I also put up, and I think I mentioned this prior to break, but there's a formula sheet that you will have on the exam. So you can kind of see it's, some of the equations that you might need that we've talked about. But other than that, I think that should do it for housekeeping stuff, unless there's any logistical questions people have for me before we start a new material here today. Any other questions? So this fifth problem set should be graded, right? You should see that score on Canvas. Other than that, I think that last problem set, the last quiz, and the last in-class quiz, which we'll have later today, should be all that we need. Okay. So, that in mind, let's talk about the last topic, which is going to be instrumental variables. So, we've talked about threats to external validity and internal validity. So, internal validity was, I'm going to start with the easier one. External validity was, we've got some results from our data set, but maybe it was just from college students. And so I might have some threats to external validity if I try to take that result and apply it to the broad kind of general population, right? I'm looking at a sample that looks very different than my population. That was threats to external validity. Threats to internal validity were things like, well, maybe our standard errors aren't quite right. Maybe we're making the wrong decision based on, statistically significant. Maybe we find some statistical significance even though it shouldn't be. That was kind of our threats to internal validity. So we said omitted variable bias was the first one we kind of started out with. We said, if we're not including controls that matter, our results are basically, they contain these huge biases. We can't even get the right size of the coefficient, let alone statistical significance. We talked about things like fixed effects can kind of help us solve this, right? Even though we don't have data on these missing variables, if I know that they're constant within a state across time, you could include state fixed effects. And that accounts for all these things that we can't even observe in the data. So we had some ways to solve these internal validity concerns. Another one that we could have that we didn't really talk about a solution to is if we had simultaneous causality. So that in ECON, this is I think one example I always use. If there's a higher quantity in the market, what is that going to do to the price? Drive it down. But if the price is lower, people are going to want to buy more. There's just kind of simultaneous causality that would just kind of go around circles. Right? So we have a solution to this, which is instrumental variables. We'll talk more about today. Errors in our variables, that was kind of our measurement error we talked about. Even though sometimes if it's classical measurement error and just random, it didn't influence the size of our coefficient, but it influenced the statistical significance. So these were all threats to internal validity. And one solution that we have, so the omitted variable bias, we could use fixed effects, but a different solution could be to use instrumental variables. The instrumental variables actually solve all three of these. So a lot of the issues that we've talked about, we can kind of solve with this instrumental variable. Okay? So what is an instrumental variable, right? And some of the terms that I'll start using that might look a little bit different than what we've talked about up to this class. So as a general kind of rule of thumb, we can think about, let's say I've got this y variable, my left-hand side dependent variable, and I'm trying to predict it using x. Well, I can break x down into two components, right? One that is correlated with the error term and one that isn't. Right? So if I kind of rewrite, right, or I think about part of x is going to be correlated with that error term and part of it will be uncorrelated with it. So we said in general what we need. One of the main assumptions we have in our regression is that the expected value of our error term given different values of x should be equal to 0. Well, that's a problem if part of x is correlated with our error term, because then this would be violated. So can we pull out the part of x that is correlated with the error term and the part that isn't? In general, when we said like we had the omitted variable bias, that violated this assumption. So what was one solution we had? Well, if I can control for that omitted variable, well, now I've removed that from x, right? We kind of think about, when we're talking about the omitted variable bias, right? We said our estimate will include the true effect plus what? The effect of the omitted variable times covariance of the included and the excluded variable divided by the variance of the variable included. So if we include that control, we kind of eliminated that. And then our errors go back to not being correlated with x. So without having data on these omitted variables, what else can we do? Right? That's what we're going to do with instrumental variables, is talk about what we can do if we don't have the data. Okay? So one term we'll start using is this idea of a variable that's endogenous. Okay? So there's two terms, exogenous and endogenous. I don't know the best way to remember this. We probably have talked about this in some of the other econ courses, but I always think about exogenous is like external. So exogenous means that it's external to what you're looking at. It is not related to. Endogenous means kind of like within, right? It is going to be correlated with what you're looking at. So we are looking at kind of this idea of an endogenous variable, right? We need something that is going to be endogenous to our error term. So something that is going to be correlated with our error term. We also need this variable to be exogenous, but exogenous to what? Exogenous to a part of our error term, right? That it's, part of the error it'll be correlated with, part of it won't, right? So we're going to have slightly different kind of rules to set out, but we're going to use these terms. Endogenous means it's correlated with, not the most technical way, but it's a good way to think about it. And exogenous means it's uncorrelated with, okay? Have you heard these terms in other econ courses? You're seeing some head nods, so this shouldn't be completely new. So if we have measurement error, if we have omitted variables, if we have simultaneous causality, which in most, if we're trying to estimate a demand equation, we have this simultaneous causality issue. So what can we do? We can use a variable, right? Or we call it an instrument, where it's going to be endogenous to our right-hand side or our independent variable x, right? So I need it to be something that is correlated with that x variable. So here I'm going to use z to represent the instrument. Maybe a different way of thinking about this, if we're thinking about our kind of two conditions here. So my first condition that needs to be satisfied if it's a good instrument, right? So instead of using z, I'll just write the word instrument in here. Okay? So if I'm thinking about what I'm doing here, I need it to be endogenous to x. So when I say y and x, we're thinking about I'm running a regression. This is the x variable that I'm looking at. Okay? So what that means, if it's endogenous, I said another way to think about that is it's correlated with, right? So we need that correlation, or I think in the slides I had covariance, but we need the correlation of the variable we include in our regression and our instrument. If they are correlated, this is something other than 0. Okay? So the covariance, or how do I find a correlation coefficient? This kind of goes back a ways. Our correlation coefficient is just the covariance between x and here the other variable was our instrument divided by the standard deviation of x. Here's the standard deviation of our instrument. So really, if the covariance is something other than 0, the correlation coefficient has to be something other than 0 as well. All right? So we need this condition to be true. Okay? So let's think about what's a good example of an instrument I've seen used before? What example did I use here? We'll go through. Let's think about I'm trying to predict wages using someone's age, right? So I have a labor data set, I've got wages, and I've got age, right? What is something that's going to be correlated with the age of the worker, right? That would be my first criteria. Okay? So the second criteria that we're going to have is that our instrument needs to be exogenous to our y variable. Okay? So correlated with our independent x variable, uncorrelated with our y variable. So for right now, we can just think about it's the covariance of y for instrument is equal to 0. It's exogenous, doesn't impact y at all. Now, I think I have in the slide, we're thinking about this as the covariance. Once we get deeper into this, we don't measure this exogeneity using that covariance, but this is a good first place to start. And based off what we've already talked about, this is a good way to think about it. Once again, if the covariance is equal to 0, you could also think about this, the correlation coefficient would be equal to 0, right? They're not correlated at all. So if I was trying to predict wage with age, something that you see people use as instruments are things that the government does. Because typically the government does something, it might impact your X variable, but not be correlated. The government makes decisions all the time that it's unrelated to like anything the policy actually is impacting, right? So what would maybe be a good instrument here? What's it called? Like the oh, there's a word for it now, I'm blanking on it, but like policies across states vary on when you can start working. So I'm not as familiar now with what they are. I know when I started working, I could work at 14 and a half in Michigan if it was under a certain number of hours, but different states you can't work until you're 15, and then different states you can't work until you're 16. So every state, or they could just change the policy within a state to increase what that minimum age you could work is. Well, that policy, that instrument, is a different variable. I could record that as like what was the state's minimum age that you could start working? That would be another variable. That would be correlated with my X variable, age, because it literally changes how early I can start working. So it's definitely going to be correlated with that. But should that policy be related at all to the wage I'm actually earning? Probably not. There might be some convoluted story you could tell with that it's having impacts on labor supply, which are impact. But, I've seen papers, there's old papers that have used this as an instrument, and they kind of show it's actually uncorrelated with our Y variable. Good instrument, right? It's correlated with X for sure, because it's a policy that dictates what my earliest age can be when I work. But it's uncorrelated. The decision of the government to change this age is completely uncorrelated with what the current wages are, right? So uncorrelated with our Y variable. So this is the idea of a good instrument. We need two conditions to be true. It's correlated with our X variable, uncorrelated with our Y variable. Is that any questions on that idea? Hear with this? So let me think. Another one I've seen used, just to make this point, I saw someone do this in a paper once, which is kind of an interesting, and I'm hoping to get some more interesting examples from this last week. So I'll take a little more time on some of this stuff to hopefully you can kind of see where this is applied to in the real world. So let's do, saw a paper that tried to predict GPAs based off of self-reported marijuana use. Well, what's going to be a problem with self-reported marijuana use? In most states, it is still illegal. So are we going to have measurement error? You better believe it, right? A lot of people are going to underreport how much they're using. So they were like, okay, what could we use once some states started legalizing marijuana? Well, now we have this instrument. So this variable Z, so this is kind of our instrument here, was simply, was marijuana legalized? It's a 1 or a 0. So an instrument doesn't have to be continuous. It could be a dummy variable, right? Well, in this case, would it meet my first criteria? If marijuana is legalized, do you think that will be correlated with marijuana usage? I mean, you're removing a huge disincentive. If we're econ majors, we should know if you remove a disincentive, people are going to do more of something, right? So we know it's definitely going to meet that first criteria. What about the second criteria? Just because the state all of a sudden makes marijuana legalized, here's where it gets a little bit tricky when we're thinking about it. It's that instrument is uncorrelated with your Y variable through anything other than the X variable that you're controlling for. So it would have to be that marijuana being legalized impacts GPAs some other way than through the fact that it might increase marijuana usage. So it has to be something other than marijuana usage that, this is where, to be technical, it's not that the instrument is uncorrelated with Y. Technically, it's uncorrelated with the error term for Y, right? So that once we're controlling for things, the only thing that it needs to be uncorrelated with is not the actual values of Y, but anything in Y that we haven't controlled for. So their example in this paper is like, okay, the state makes marijuana legal. I mean, other than the impact of marijuana usage, how should that impact at all a student's GPA, right? And I forget, they came up with like one or two very convoluted stories that don't really even make a lot of sense. And they then go through the steps to prove, which we'll kind of talk about here later today, we can prove that it's in fact uncorrelated with the error term, right? So we're trying to get these two things to be true. We have some statistical tools that we can test to see if these two things are true. We don't just have to go based off of intuition. But usually when you start out with an instrument, the first step is I just try to think of something that would satisfy these conditions, and then I use the data to tell me whether or not these conditions are met. Does that make any sense so far? Or at least enough before we see this kind of apply to some actual data sets? Okay. So there we go. I wrote it out a little more technical here. Instead of instrument, I'm using Z just to represent instrument. If you look at textbooks or if you go out there online and search, generally Z, they'll kind of represent your instrument. It doesn't have to be uncorrelated with Y. It has to be uncorrelated with the error term in Y. So once we've controlled for everything else in our regression, is that instrument uncorrelated with Y? That's the second condition that we need to be met. But really, for the sake of what we're doing, you can almost think about it as it simply just needs to be uncorrelated with Y, right? So these are our two conditions. Okay. So we'll start to think about what we're going to do to actually run these instrumental variable regressions. So what we'll first do, we're going to have multiple regressions we actually have to run, okay, when we're doing instrumental variables. So the first is going to be, we'll take that X variable. So in my previous one, that was like marijuana usage. I will then run a regression where I include as the explanatory or the independent variable, my instrument. So once I run that regression, I'm going to predict the value of my independent right-hand side variable X. Okay? Now, we've done this before. You run the regression. You could use the predict command to simply come up with what those predicted values for X would be. Right? So this up to this point, even though it's not Y and X, it's X and our instrument Z, it's the same procedure as when we were trying to come up with predictions for what Y was based off of a single X variable on the right-hand side. Once we obtain those predictions, we're then going to include them in what we call our second stage. So instead of using the actual values for X, in our second stage regression, where we initially wanted to know what was the impact of marijuana usage on GPA, we won't use the actual marijuana usage in our data. We'll use the predicted marijuana usage that came from our first stage regression. So by doing this, a way to think about this is in that first stage regression, because we're coming up with only predictions, our predictions won't include this error term of what our instrument doesn't explain about X. All right? So we're not using the actual X values in that second stage, we're using our predicted X values. Okay? So anything that was in this error term will no longer be in our regression, right? Anything in this error term should be completely uncorrelated with our Y variable, right? Or should be uncorrelated with the actual error from the original regression that we wanted to run, right? Y on X. Just now, instead of using the actual X values, we're using our predicted X values. If we do this and our two conditions are met, we will obtain a coefficient estimate that's unbiased, right? It removes the bias that existed because of omitted variables, simultaneous causality, measurement error, et cetera. So let's kind of take a look at this, right? I've got it broken down here. I think we'll kind of hold off. I want to show you what this looks like in practice. So let's go over to Stata. We get too lost into the weeds here. Pulls this open for me. There we go. So here's the do file that I've got posted for this week. Looks like I'm going to have to minimize this. A file, open. So the ones I put up here, we're going to do 14 now. I think the first thing I have this Ivy Health data set that I posted. So I'm going to want to open this up. Kind of had this working off of my laptop. Forgot to just kind of change the location of where that exists. Okay. So I'm going to open up that Ivy Health data file. I'm going to run my naive regression. So the first regression I'm going to run, I'm trying to predict medical expenses based off of a dummy variable for whether they had health insurance, right? Whether or not they had pre-existing illnesses, right? And then their age and then the natural log of their income. So I'm just kind of using some natural logs here so we can start to also get some practice going back over nonlinear regressions, okay? So if I run this regression, I'll get something that looks like this. So how would I interpret my coefficient on the natural log of income? So here, between income and medical expenses, if I've taken the natural log of both, how would I interpret that coefficient estimate? So I take the natural log, what are the units now in?
Percentage.
Percentages, right? So it's a 1% change in income causes my y variable to change by 0.017%. Everything's in terms of percentages. It's not a linear log, so I don't have to do any kind of adjustments like dividing or multiplying by 100. It makes it a little bit easier here, right? So a 1% change in income increases my medical expenses by about 0.017%. Holding all these other factors constant. So, and then I'm going to kind of look at this and think, okay, well, what's something that could be a good instrument here? Because I know that if I have health insurance, in general, what is that going to do to my out-of-pocket medical expenses? Well, it's the whole idea of insurance. It's going to pay for your medical expenses, right? So I know that if I have health insurance, well, here I get a positive effect. So having health insurance actually makes my medical expenses higher. That's because it's a very naive regression, right? Who is likely to choose to have health insurance? Someone who's choosing not to get health insurance?
Aren't sick or
yeah. My grandpa, who's like 85, still goes out and cuts wood every single day because he enjoys it and sells it like on the weekend, right? He has government health insurance, but up until he retired, he didn't have health insurance. Jesus Christ. But, right, we're going to have selection issues, right? So automatically we have an omitted variable bias, which we know people that get health insurance are typically going to be sicker. So they're automatically then going to also likely have higher medical expenses. So we have an omitted variable bias problem, right? In fact, this goes against what our intuition would say, right? We have a positive effect from having health insurance on my medical expenses. It should be negative. That's the whole point, right? So we know we have an omitted variable bias. Let's try to solve this with an instrument, okay? So I was kind of looking through this data set. Now notice I have the same controls as I had in my original naive regression. Age, pre-existing illnesses, and then what? Natural log of income. I also had the state's Social Security income ratio. So how much of your income is replaced by Social Security, right? So essentially, if that percentage is higher, that ratio is higher, would I be more or less likely to need health insurance? If it's higher, the state is already going to pay for it. Am I going to go out and get private health insurance? No. So I know that these two things should be correlated. If I use the state level Social Security income ratio, it should be a good instrument in terms of our first condition. That instrument, if I'm thinking about getting private health insurance, the instrument of the state's Social Security income ratio, those two things should be correlated, right? So it should meet that first criteria. Now, what was I trying to predict? So here, if I use that instrument of Social Security income ratio, what was I trying to predict? I was trying to predict medical expenses. So for any one individual's medical expenses, does the state's decision about like how generous they're being to their population, should that at all impact what my medical expenses are? I mean, like once again, maybe there's some, it's probably a much more complex issue in the sense of like states that maybe are a little bit more kind in terms of offering higher Social Security income ratio. Maybe they don't offer as many free health programs. So maybe there is something we're not controlling for. But in general, it's a state level policy. Shouldn't be impacted at all on these individual level medical expenses. right? So a lot of the times as instruments, like state level policies are kind of nice tools, right? Or nice instruments. So we think that it likely, the decision of the government should be uncorrelated with the medical expenses of the individual, right? So hopefully our second condition is met as well, right? So I'm going to show you how you would run this instrumental variable regression, and then we'll think about the statistics that tell us whether or not it is a good instrument, whether or not our intuition is correct, okay? So the first thing that we'll do is I'm going to run a first stage regression where I know that there's some selection of who's getting health insurance. I know there's this, it's omitted variable bias that's screwing up my coefficient. So I'm going to run a first stage regression where I look at that X variable that I want to instrument. So I'll look at health insurance. That will now become my Y variable, essentially, or my dependent variable. Now, when I'm running instrumental variables, I have to include all of the other controls as well. So I will still need to include illnesses, age, and the natural log of income. But the second thing, and I can put it in any order in the examples I show you, I just generally always, to make it easier, and this will be the true on the exam, I put the instrument as the first variable. That way we know, like, this is the instrument that we're looking at. So we're going to try to predict our X variable of health insurance using that instrument, but still holding up everything else constant, okay? So if I do that, right, I'm then going to use the predict command to create this new variable that just predicts health insurance for the different values of these X variables. That was our predict command. So predict, create this new variable, which is first stage, or let's see, I could even name this something different that might help. So let's say it's predicted health insurance. All right. So that's the name of my new variable. I'll run this first stage regression. Sure enough, I can see that social security income ratio, what is evidence that it's correlated with whether or not I get health insurance? So if I run a regression, I'm trying to predict whether or not I get health insurance. That's my Y variable now. Social security income ratio, that's my X variable. What tells me if those two things are correlated?
Statistically significant.
Yeah. I just have to look at the p-value associated with that coefficient. That's a better actual measure than simply looking at the correlation between those two. I set it up initially thinking about it just as a correlation because that's an easier way to think about it. But a better test would be, once we control for all other factors, is the social security income ratio, is it correlated with that X variable? All we have to do is look at the statistical significance of that coefficient on the instrument we're using. Here, test statistics -14, hopefully we start to recognize anything over like what, 2.58 is going to meet that highest 99% confidence level threshold. We've got a p-value basically 0. Yes, these are correlated. Our first condition's met, right? Pretty strongly, in fact. Okay. Does that make sense when I'm saying they're why? Okay. Once again, not cumulative, but we're using things that we've talked about prior in the semester. So once I run this, that was my first stage. I then predicted that X variable I originally wanted, which was health insurance. So if I look at the data, I'm now going to have whether or not they had health insurance. Here's kind of a unique one. Well, now when I predict whether they have health insurance, originally that data was ones and zeros. It was a dummy variable. Well, my predictions won't be ones and zeros. So these will actually kind of represent like the predicted probability I had health insurance or not. Right? So my predictions will look very different from the original X values. I use this example to like make that point. We started out with a variable that was ones and zeros. When we predict it from our first stage, we get all these other values in between 0 and 1, right? So that's the variable, our predicted X value, that we then want to include in our second stage. So I called it first stage before. Once again, I thought maybe just to kind of help you think about what we're doing, I predicted that X variable health insurance. For my second stage, I'll use my predictions, but I go back to my original regression for what I wanted to understand. What was the relationship of medical expenses and whether or not I had health insurance, right? So now I'm back to my Y variable, and I don't include the instrument in my regression, but I use the instrument to come up with predicted values for this X variable I knew had an omitted variable bias problem, right? And then I'll include all of those original controls as well. Illnesses, age, log of income, whatever else I had as original controls. Now, when I run this regression, well, here, let me run the naive one first, just so I can like scroll up and down very easily. So here was the original naive regression. I'm going to run that one, and then going to run that second stage regression where I'm using the predicted X values. Okay. So there we go. So here is our original naive regression. Remember, we said we thought that this should be negative, but it was positive. Right? Once we run our instrumental variable regression, now notice when we use those predicted values from our first stage, what is our coefficient now? Statistically significant, and it now has the sign that we would expect intuitively. That when someone has health insurance, and really by instrumenting with that social security income ratio, we are now controlling for all those other omitted variables that we didn't have data on, like the health of the individual. We're controlling for all of that without actually having the data, right? And so now we've eliminated all that omitted variable bias. What's the actual coefficient on health insurance? Should be about negative 0.85. Right? So this is a good example where you can see the instrument, we've got a huge omitted variable bias. It might dramatically change the size of the coefficient we see. And if it changes the size, it can also change the statistical significance as well. So any questions over anything I did there before we keep moving? If you want something to kind of go along with this do file, I'll write this out and maybe this will kind of help, right? So if this helps when you're doing instrumental variables, always think about what your original regression, what you actually want to know. So ours was, and I'm not going to write the natural log just for the sake of keeping things kind of short. So we wanted to know whether or not having health insurance impacted medical expenses, and we had a bunch of other controls as well, okay? Well, we know there's no omitted variable bias, so what are we going to do? We're going to use an instrument, our first stage regression. We take that X variable we were interested in, and here I technically shouldn't write these as betas because it's like a different thing, so we can use, I don't know, gamma, right? So I'm going to use my instrument, which for us was social security ratio. So this was our instrument. And then all of our additional controls. We then kind of use these results to come up with predicted values of health insurance. We then go to our second stage, where our original question was, how does health insurance impact medical expenses? So we're now going to be looking at, okay, our medical expenses, how are they impacted by health insurance? But instead of using that actual variable, we're going to use our predictions from the first stage. So what that first stage did was remove any of those omitted variables that were influencing health and the decision to get health insurance that we didn't have data on. And then we'll have all of our additional controls as well. Now, once we get to that second stage, the statistical significance, once we're in this first stage, the statistical significance of that instrument will tell us whether or not that first condition was met, right? In our example, we said it was strongly met when we looked at that first stage. Now, from our second stage, we can determine whether or not the second criteria is met, which is that instrument exogenous? Is it going to be exogenous to our Y values? Right? So we'll kind of go back and kind of think about this. Right? So I have another way of doing this, but that was kind of our general setup. I'm going to use the exact same thing, but show you a little bit of a shorthand that we have in Stata. So instead of running the first stage, predicting the X values, and then running the second stage, if we use this IV regress command, Stata will do all of this behind the scenes for us, okay? So the syntax of what we're going to use, I kind of tried to write it in general here. We'll take whatever our Y variable was, that was medical expenses for us. Then our X variable, which was health insurance, our instrument, which was social security income ratio, and then all of our additional controls, okay? If I run this regression, it will only give me the final second stage results. So if I run this, hopefully I get the exact same thing I see here. So sure enough, I'm getting the exact same kind of values here. Now, We haven't talked about one thing. Our standard errors will be a little bit different if we use the IV regress command. Probably won't talk about that today. It'll probably save that for Thursday's class. But they're going to be very, very close, right? There's a reason why they're slightly different, but we'll dive into that kind of next class. But we can kind of see here, we're getting the same coefficient estimates, right? So it's just doing all of the work behind the scenes for me. It's not showing me the first stage. Well, that's kind of a problem because the first stage, what did we say? That told me whether or not my first criteria was met. So the other thing that you can do, and I have it up here, if you do want to see the first stage, if you put comma first, when I run this IV regress command, it'll show me both that first stage regression results and then the second stage, right? If you don't include first, it'll just kind of skip that altogether. So this is kind of a shorter hand way of doing the exact same thing. Questions before we keep moving here? Yeah.
Could you re-explain how you chose the Social Security and income ratio as the instrument to use for the regression?
Yeah, so I was just trying to think of something that would be correlated with the X variable. My X variable was whether or not I get health insurance. So if I know that the state already gives me a higher ratio of my income, this is like once I retire, the money that the state pays, like they pay 50% instead of 25%. Well, if they pay 50% instead of 25%, am I more or less likely to also get private insurance? Less likely, right? Because they're paying for more of it. I don't need additional insurance. So we know that state level Social Security income ratio is going to be correlated with the decision to get private health insurance. So it met the first criteria. We also need it to be uncorrelated with my Y variable. Now, when we say the Y variable, technically it's uncorrelated with the error term. So it's that instrument of Social Security income ratio has to be uncorrelated with medical expenses or is not correlated with medical expenses through anything other than what we've already controlled for. So it would have to be impacting my medical expenses through something other than my decision to get health insurance, other than my pre-existing illnesses, other than my age, other than my income. State level policies tell me something that's going to be correlated with, other than that, that's going to, so that it would be correlated with medical expenses. I can't think of anything, right? I don't know. Well, we have ways to test for this, which we haven't quite gotten to yet, right? We've talked about that, how we test for that first stage. We'll talk just in a second about how we test for that second stage. But just based off intuition, the policy levels of the state are likely to be uncorrelated with my medical expenses once controlling for all these other factors. So that's just the intuition of why we thought it might be a good instrument. So I had another one, which I put here, which was firm location. And I believe this was where this was the number of, this was whether or not the firm, health insurance firms, were actually located in the state, right? So there I might be thinking about if there's more health insurance firms in the state, it's more likely I get health insurance because if there's more firms, there's more competition, which would drive the price down, which makes more people more likely to get health insurance. But the fact that there's more firms, is that going to influence my medical expenses through anything other than the price? That's probably not, right? Now we can check to see if that's true. So my second example, let's look at that first stage result. If I instead try to use firm location, the number of firms that are located, health insurance firms located in that state, if I run this and I want to look at my first stage regression, oh, well, I thought it might be good. But if I'm looking at firm location, oh yeah, okay. It still looks like it's a pretty good instrument, right? P-value is 0. But if I had to choose, gun to my head, right? If I look at the first stage regression here, which of these is a better instrument? Social Security income ratio, P-value is 0. Social Security income ratio, compared to the Social Security income ratio, firm location, P-value looks like it's 0, but it has a half as large test statistic. So which of these is actually more statistically significant? Using that Social Security income ratio, that would be a stronger instrument, right? But both of these would actually meet our first criteria. And so it's not always obvious that these instruments might work. Sometimes it's just running the regressions, looking at the first stage results and seeing, does it meet that first criteria? Is that
Yeah, so
kind of
like,
a long answer, but
no, so like for the problem set,
Mhm.
working with this, would we be looking through the set or would you give us?
I tell you what to use this.
Okay.
Yeah, no, I'll tell you what to now. On the exam, we work through some of the practice exam questions. I might try to give you what I think is a pretty easy example, or I might give you a hypothetical instrument and you have to tell me why you would believe would meet the first or second criteria. More likely, I'm going to be giving you results and then you have to see, does it meet the first criteria? You look at the p-value from that first stage regression, see is it below our conventional levels, right? And then we haven't talked about the second criteria yet, but it will be something we can look at to see whether or not it meets the second criteria as well. But no, I won't ask you to like come up with these off the top of your head. It's actually pretty tough to do. People like get very protective when they come up with a really good instrument. They like don't like put that out there because it's a unique instrument and someone hasn't thought of it. You can get a paper published and make a lot of money, and you can get some really interesting results that the firm will pay you for it, things like that. I digress a little bit, but not as great of a reason, or not as great of statistical support. But I could also think about what's a very basic way I could kind of pick up whether or not these conditions are met. Well, we said if Social Security income ratio is a good instrument, it should be correlated with health insurance, right? So if I look at the correlation here, I get negative 0.03. So it looks like there is some correlation between that. Now, is it uncorrelated with the Y variable of medical expenses? Well, ideally, if it was truly completely uncorrelated, what value would I want to see here when I look at my instrument and its correlation with that Y variable? I want to see 0. If I actually run this, it's small, but it's not 0. Okay? So this is like our first look. This doesn't necessarily mean, because I haven't controlled for anything else, right? So how can we control for other factors, just like the ones that we included in our regression above, to see, is this actually going to meet our second criteria, right? So what do I want to do here? Well, let's see. Go back to the slides. I'm going to skip ahead a little bit here. Here we go. So we'll come back to those other slides. But because of based on what we've talked about when we're in class, I want to kind of make sure we hit on this. Okay. So that's first criteria, we can see whether or not it's going to be correlated with our X variable. What if it's kind of covariance is pretty close to 0? We can't have weak instruments. In both the examples we just looked at, that p-value was basically 0, so they're pretty strong. What if the p-value was like 0.08? Well, we would say it's a good instrument at the 90% level, but not quite at the 95 and 99%, right? Just because the p-value isn't 0 doesn't mean it's a bad instrument. It just means that some instruments are weaker than others. Okay? Now we can also kind of look at the strength, not just based off of that coefficient. We can also look at the F-stat that comes from our first stage regression. Okay? So that first stage regression essentially is going to be how much of our regression explains the variation in that X variable. So if we go back to our example here, and I'm thinking about using the Social Security income ratio. Okay? We already said that it looks like it's good based off of that coefficient, but now I'm telling you another good rule of thumb is simply if the F statistic is greater than 10. So if I run that first stage regression, I look at the first stage regression results, it'll give me an F statistic here, which is controlling for all other factors. And one of those factors is this instrument. What is the variation, or am I explaining more than 0% of the variation in that X variable that I'm trying to predict, which was whether or not I get health insurance? Well, here my F statistic, I said the rule of thumb is it greater than 10? It's 185 here. So this is a very strong instrument, right? The closer we get to 10, the more evidence we have that it's weaker. So based off of what we already did, if I instead use that firm location, and this is where they won't always be 1-to-1, but they're going to be correlated. They're going to be generally tell us the same thing. For that firm location, remember the p-value was still 0, so it still looked like a good instrument, but we said it was weaker, right? Because the test statistic was half as large. So if I run this regression, I look at the first stage using firm location as my instrument, what do you think is going to happen to that F statistic? Instead of 185, likely going to be smaller. If it's not as strong of a statistic, or sorry, it's not as strong as an instrument, our F statistic should be smaller. So sure enough, if I run that, look at my first stage regression, instead of 185, I get 146, which is still very strong. But if I'm kind of choosing which instrument to use, the one that's stronger is going to be the one that has a higher F statistic or has kind of that higher test statistic associated with the coefficient. Both of those things will be evidence that it meets that first stage criteria. Any other questions on that idea before we keep moving here? Okay. We have time, so we have 20 minutes left. Trying to think what we'll have time for here. I think we'll save this till next class. So we're not going to touch on this today, but kind of just leading us into what we'll talk about next class. We really just looked at two different ways to determine if that first criteria is met. Looking at the p-value associated with our instrument's coefficient or looking at that F statistic from our first stage regression. Next class, we'll look at statistics that tell us whether or not the second condition is met. So we've only talked about kind of the intuition today. We'll look at the statistical support for whether or not it's an endogenous instrument, whether it's uncorrelated with our Y variable next class. But one thing I did want to kind of take a look at today that I think is maybe helpful for this, right? So first of all, I wrote this out in the context of our examples earlier. So these are like the steps to running these two-stage least squares regressions where I have a first and a second stage. I regress that independent X variable on my instrument, come up with my predictions. I then include, instead of the actual X variables to predict Y, my predicted X values. I then have an unbiased coefficient. It's actually kind of interesting, right? And I'll kind of walk through this quick. But if I were to rewrite kind of this, I think about my kind of simple linear regression, the covariance of Y with this instrument should be the same as the covariance, if these two equations are equal, would be the covariance of what I have on the right-hand side with that instrument as well. So if I then kind of rewrite this right-hand side, it will be the covariance of my intercept with the instrument, the covariance of beta 1 times X with the instrument, and the covariance of my error term with the instrument. Okay? Well, the instrument, how should that be correlated with my intercept? The intercept is just the starting, that shouldn't have any correlation at all, right? So that would just drop out. That should be 0 always, right? Now, if that instrument truly is endogenous, it's not correlated with my Y variable, then it should be uncorrelated with its error term. So if it truly is endogenous, it's not correlated with the error term of my Y variable, this should go to 0 as well. What would I just simply be left with? The covariance of beta 1 X and Z. So this is all I would have left. Well, notice if I just rearrange this, what is my coefficient beta 1? It's the covariance of Y with my instrument divided by the covariance of X with the instrument. So let's see if we can prove this to ourselves with data. All right. We thought that the Social Security income ratio was a good instrument. Oops. If that is the case, I should be able to look at those covariances, and the ratio of the two should give me what I was seeing from my second stage results. Okay. So we'll go back here. And we're going to go up here. All right. So I can look at that covariance of medical expenses with Social Security. That was the covariance of Y with my X variable. Here's the correlation. Sorry, that's not, I'm saying this wrong. The correlation of the instrument with my Y variable, and then the correlation of the instrument with my X variable, right? Instead, the ratio of those two should give me that coefficient that I was seeing, which was, oh, where was that now? That was firm location. We have, which should be about negative 199, right? So, oh, no, it's not. We're going to go, I have to go all the way back. Where were we using that Social Security income rate? Well, let's just rerun it. So we'll go back here. Where was our, we'll get rid of the first stage just so we don't have to look at it. So let's look at when we were instrumenting using Social Security income ratio. The result that we got was what? Negative 0.85. That was the kind of coefficient we saw. If we take the ratio of those covariances, it should, if it's a good instrument, give me about that same value. So I can run these correlations. Here was the correlation of Y with my instrument and the correlation of X with my instrument. So I can obtain those two values, 0.0312 and negative 0.0379. If I take a ratio of these two, in fact, I can even use the display command. I can just make that a comment. Instead of having to type this out in a comment, right? I should be able to take those two. See, sure enough, we get negative 0.82, pretty close to negative 0.85. Also, I was rounding these to the fourth decimal, so there's going to be a little bit of discrepancy there just with rounding, right? But if it is truly exogenous to Y and endogenous to X, our instrument will simply be the ratio of those covariances, right? Now, that only works if it is completely uncorrelated with our error term, which in practice, will any instrument have a covariance of exactly 0? Probably not. So this is going to be something, even if it's a really, really good instrument, this will still be some value, in which case it would still kind of end up there in our denominator. So it's going to be a little bit off, but it's going to be really close if it's a good instrument. The worse an instrument is, this value is going to get larger and larger, and then that ratio is going to be further and further off from being completely accurate. But if we ever had a truly uncorrelated instrument that was truly uncorrelated with Y, it should just be the ratio of those covariances. So let's go down here and we'll mark where we were at today. So this is where we'll kind of pick up next class. Okay? So we'll kind of finish up this example talking about the second criteria. I then have a second example that we'll kind of work through as well. But for today, it's published. I think I choose 30.52. Let's see if memory is good here. Nope. Oh, I did this. 13.00. Okay. So 13.00 should be the code that gets you into the quiz for the day. Scroll all the way down here, last in class quiz. And we'll kind of think through hopefully basic questions that kind of summarize what we've been talking about. So let's go to preview just so we can't see these, and we'll kind of talk through these. So the most basic setup, kind of our instrumental variable approach. So 13.00 is the code that gets you in. So our instrument, here we have to think a little bit harder because I'm not writing it out in terms of Y and X, but this is where we need to, at this point in the semester, be familiar with these terms. What is our dependent variable? That's the variable that's on our left-hand side, the variable we're trying to predict. So what should the instrument be with our dependent variable if it's a good instrument? Uncorrelated, all right? So we should think about it should be completely uncorrelated with our dependent variable. For that other criteria to be met, we're thinking about the independent variable X, the instrument needed to be correlated with it. We need it to be uncorrelated with our dependent variable, and we then need it to be correlated with that X or that independent variable. So this is where we won't always use Y and X. We need to remember kind of our dependent variable is that Y left-hand side variable, independent X variable, right-hand side variable. Those are all named for the same thing as well. That was just our initial setup of what we needed to have a good instrument. Now, we talked a little bit about this. There's two things we can get from the first stage that tell us if this criteria is met. if the instrument is in fact correlated with our X variable. So the first thing was when we run that first stage, we can look at the statistical significance of our coefficient. So if I'm looking at the 99% level here, and I want to know, I'm looking at that first stage test statistic. In fact, type this out quickly. This should not be exogeneity. This should read endogeneity. Or sorry. Yes, this should read endogeneity, right? Is it correlated with X? Okay. So I'll edit this after class, but this should read endogeneity. Time this quickly. So here's where we're going to do a little bit of review. If I'm thinking about that p-value, I'm getting a little bit tricky here. But when I look at that statistical significance, in order for my p-value to be less than 0.01, what were our kind of cutoff test statistics? So we had 3 test statistics that gave us either an alpha of 0.1, 0.05, or 0.01 in our tails. Right? And this is always a two-tailed test. So if we go back a ways, these kind of cutoffs were always going to be 2.58, 1.96, and 1.65. Okay. Now, if I'm using the p-values, I can simply compare p-value to alpha here. But if I'm looking at the test statistic, which we might want to start doing because these p-values get so small out to the third decimal, they might look the same. We need to know that a larger test statistic would also be directly related to that, there would be a smaller p-value. Okay. So if I wanted to say this is endogenous at the 99% level, the coefficient needs to have a test statistic that's larger in absolute value than 2.58. It needs to be somewhere out here. Okay. Everybody clear on that? I'm using the right-hand side here. It could be it's negative and it's somewhere out here. That's why we say it just in absolute value, it needs to be larger than 2.58. Because if it's larger than 2.58, we know its p-value would be less than 0.01 associated with that 99% confidence level. Okay. So that second part should be that in absolute value, right, this should be greater than 2.58. Now, the other statistic we had is we can look at the F statistic from our first stage. And basically what that F statistic is telling us is, can we say that the amount of variation we can explain in X, right, that was our first stage regression, we used X as the dependent variable, is it different from 0? So the higher that F statistic gets, the smaller the p-value, we could say that, yes, we are explaining more than 0 at higher and higher statistically significant levels. I said a good general rule of thumb for instruments, anything over 10 we should have enough statistical significance to say that it is a good instrument. It is endogenous to that instrument is endogenous to the X variable. So here we just need the F statistic to be greater than 10. We also need for that coefficient's test statistic on itself to be greater than 2.58 in absolute value. Okay. So there we should be greater than 10 and greater than 2.58. Any questions? I get it. We're keeping moving. All right. So, got 10 minutes left. I want to show you one more example. We'll do it relatively quick, and then we'll kind of repeat or pick up back up on this when we come back on Thursday. So, I've got this free data set, which is wage, right? Wage 2. We're going to open that up. Let's say I run this regression, very naive. I'm trying to predict wage using education, experience, age, and married, right? Well, I know that there are likely a lot of other things correlated with education that I'm not controlling for. So if I want to know the true impact of education on someone's wages, there's a lot of omitted variable bias. So I'm trying to think of an instrument that would be correlated with someone getting higher education, but uncorrelated with their wage. This is tough. Like if I think about like my family's income, It's likely going to make it more likely I go to college or have more education, but it's also likely going to put me in opportunities where I can earn higher wages, right? Some nepotism, right? And it's hard to think of other attributes that wouldn't be correlated with both of those. And we can't have it be correlated with both. It is only correlated with our X variable, uncorrelated with Y. So in this data set, they had kind of mother and father's years of education. Now, this is an older data set. I'm not trying to be, a sexist. So it's like older data coming from like the 70s and 80s. Primarily, the person that had the highest education in the household was the father at that time. Right? Obviously, if we're using newer data, we might want to use a different instrument. But given that this was older data, I'm thinking about, would father's education be a good instrument? Well, if your parent had a college degree, you can think about it this way. Do you think it's more or less likely you obtain a college degree as well? More likely, right? Even if income made was the same, they have more of a working knowledge about how application processes work. They would have, knowledge about how to navigate, maybe even working and going to school at the same time. Even if we're not thinking about these are privileged backgrounds, just the fact that they went to college, they're going to have more information to help their children go to college as well. Right? They also are likely to have higher wages, would then give their kids more opportunities to have higher GPAs, be more likely to meet admission standards. So it's likely going to be correlated with the education of the child. But just because my father has a higher education, is someone going to pay me a higher wage because my dad has a college degree? No, right? I mean, and it has to be that my father's education is correlated with my wage through anything other than what we've already controlled for. So yes, my father's education might make it more likely my education's higher, in which case I'll get paid more. But we're looking for, how does my father's education impact my wages through anything other than what we're using it as an instrument for. I find it hard to think of like really good examples there. Once again, maybe there's, if we looked at certain markets, maybe like a political market, maybe there's something there. But, I think it's probably going to be a pretty good instrument. So what can we do? We can use this IV regress command. I want to look at the first stage results. What do I have from this first stage that suggests that using father's education was a good instrument? First thing, we just talked about it on the quiz, is that the F statistic is way greater than 10. Right? It's 109. The second thing we can look at is what? The statistical significance of that instrument, which here, highly statistically significant. So at least for that first criteria, it looks like we have a good instrument. Okay. Next class, we'll kind of take a look at, okay, maybe it meets the first criteria, but doesn't meet the second criteria. Okay. So we'll focus more on that second criteria next class. I'll probably revisit some of the things that we talked about today, even like that ratio of the covariances. When we're looking at this next class. The examples that I've kind of set up today, we're thinking about omitted variable bias. I'll have an example next class where I actually have, instead of omitted variable bias, we have a variable that has measurement error, and show how using an instrument there will also kind of correct for the measurement error bias that exists. So we'll take a look at this kind of next class, a complete discussion on instrumental variables, anything that you would need. Once again, based off what we did today, you can probably get a pretty good start on those questions on the problem set that are related to instrumental variables. And then after class Thursday, everything that you need to kind of make sure you can complete that problem set. With one more thing I told you to remind me to talk about, which was what? Quiz. Okay. So the sixth quiz, you guys are here. You don't really want to, I know that you guys, semester is getting busy, right? Some of you might even have finals late next week, right? So I don't want to assign a quiz after class Thursday. I gave you sample questions that were instrumental variable questions that would prepare you for a sixth quiz. You can use those as study materials for the final, not going to give you a sixth quiz over material. Okay? So the only thing really left, since we did the in-class quiz today, is that problem set that's due next Tuesday. That's the only other thing you have to complete before the final exam. Now, you have to complete a sixth quiz, which I'm going to give you, but it's literally a survey. So it is asking you things that you want to review more of next week, things that you found difficult in the class, maybe different types of presentation that you found easier or more difficult. And that will kind of direct how I will probably kind of go through the review next week as well, based off of some of those questions. So what I would like you to do is get that quiz filled out. I will post it after class today. Complete that by the end of the day this Friday. Once again, once you sit down and do it, it should take you, I hope you put a little bit of time and effort into it, because the more time and effort you put in, the more effective next week will be. But once you sit down and take it, it shouldn't take more than 15 minutes, right? So getting that done by the end of the week, I can then take a look at it over the weekend prior to next Tuesday's class, and I'll kind of direct the way that I'm going to do those review sessions next week. I say review sessions, review classes, based off of those responses. Okay, so you'll see that 6 quiz pop up. Don't freak out about studying for it. It's just going to be survey-based questions. Okay, and then it's still going to count like it's a quiz. So trying to be friendly, you all do it. What should happen to your quiz score? I mean, as long as you complete every question, it has to go up. No one in this class has 100s in all the quizzes, right? There's some who've close, but not all, right? But that also means if you don't do it, this is where I don't get angry if you don't do it, but it just makes me sad, right? Because I'm trying to give you free points. Okay, so you'll see that quiz pop up here probably in the next 15, 20 minutes. Due by the end of the day, Friday, just survey-based questions. Okay? All right, I'll see you guys on Thursday.
I had a couple questions.
Yeah.